Hello, everyone, and thank you for attending today's webinar, AI and Functional Safety, Navigating AI in Safety Critical Software Development. My name is Sarah Gagg, and I'm the Marketing Program Manager for Perforce QAC and Clockwork. Before we begin, I'd like to cover a couple housekeeping items for our viewers. First, at the bottom of your audience console, you'll find a few widgets for questions and additional resources. When we have questions for the presenter during the webinar, click the Q&A widget and submit your question. We will answer as many questions as possible at the end of the presentation, and if we run out of time, we'll get back to you via email. If you need any tech support during the webinar, please use the help option. And finally, a copy of today's slide deck is available upon request. Please drop your email in the chat box or reach out to the team if you'd like to receive a copy of the deck. We will also email you a link to the recording of this webinar within the next few hours. With that, I'll introduce our presenter for today, Jill Britton, Director of Compliance at Perforce Software. Jill, thanks for joining us on today's webinar. You may take it from here.
Thank you, Sarah. So our subject for today is AI and functional safety and how to manage AI in safety critical development. Well, first of all, a little bit about me. I've been working in the embedded software environment for many, many years. And I've worked in a lot of industries. I've worked in automotive, I've worked in defense, I've even worked in education. So I have a sort of a broad experience of software development. As it says here, I am the Director of Compliance for the static analysis tools here at Perforce, and I've been in this role for about 10 years now. So, what are we going to talk about? AI in safety critical applications. Well, first of all, let's think about AI in software development generally. Now, AI is becoming more mainstream. It's very rarely that you get a new product now where you say, oh, what are you doing about AI? I know with our own products, we're constantly being asked, are you using AI? What are you doing about AI? And whatever like that. And of course, safety critical applications are no exception. And there's very good reasons for this. It can speed up development. It can allow sort of our highly skilled developers to do the bits that they do best, which is look at the functionality, and design. But it can also look at initial scans of code. And it can do things like auto remediation. There's a silly mistake here. There's a semicolon missing. I'll put it back in. It can look for code duplication, which of course is always a danger area because did you actually mean to repeat this for loop? It can look at if comments match the code. And it can do general issue triaging, keep about what's going on. And potentially it could be a complete replacement of the structural analysis engine. But the question we have to ask is, are AI systems safe? Now, they bring many benefits to society. They can solve urgent challenges. We all hear about how AI comes into research and can come up with an answer for a problem that the humans have been trying to solve for years. At my local hospital, they're using AI to look at X-rays because they can work continually, they aren't preoccupied by something else, and can spot small changes. And it makes applications more innovative and indeed more secure. However, they must be developed, deployed and operated in a secure and very responsible way. We can't let AI just go off and do exactly what it wants. Now, currently, software for safety critical applications is guided by functional safety and security standards, which we'll talk about in a few minutes. But the question we're asking is, are these sufficient for AI systems? So, functional safety. What is it? And why should we actually be concerned? Well, functional safety, at its sort of lowest level, protects a user from the technology. For example, in a vehicle, it makes sure that the brakes are working. So if there's any changes in the software that control the brakes, they're checked. But more than that, it also protects the technology from the user. Users are well known for actually not doing what you expect them to do when they have an application. So basically, it's the implementation of protective measures to eliminate or to mitigate hazards caused by a failure, that's where we get the technology, or unintended behaviour of the system, which could be the system itself, or it could indeed be the user. And this is especially important for safety critical applications. Now, functional safety standards prevent system failures that would be hazardous to human health or to property, or in the absolute worst case, could be life-threatening. They minimise the risk, and that is an area we always talk about with functional safety, the risks. So we look at the risks associated with product design and development and then minimise them. And systems covered under functional safety are designed to be automatically prevent dangerous failures or to allow users to control them when or if they occur. So if we look at the life cycle, which is generally the software life cycle, but we look at it from a safety aspect here. We look at throughout the development process, all the safety related aspects at a very detailed level. So we look at the requirements specification. Are there any safety aspects here? Include design, make sure that our code is safe, in the implementation, and then in the verification and validation, of course, we're constantly looking, is this safe? And let's check that it is, etc. And this goes right through to decommissioning. Now, many industries have their own functional safety standards. So we've got a few of them here. For example, EN 50716, which is for the rail, or DO 178B or C for aerospace, and my own personal favourite, ISO 26262 for automotive. But those that don't tend to use ISO 61508, which is a general industrial standard. So that we have industries, they all know that they need to be functionally safe. So what does it actually mean to be compliant with a functional safety standard? Well, it means that we have processes specified and we follow them, that we have requirements, that we know what our requirements are, that we code to our requirements, we test to our requirements, we make sure that everything is there. If there is a problem, we look at why, and what is the sort of remediation here, or the mitigation of that. We make sure that these processes are followed throughout the lifespan of a product. As we said, safety applies from a very initial requirements phase right through to decommissioning. Now, the thing about these processes actually makes us more productive. We know what we've got to do. We've got these standards. We're following it through our whole aspect of development, and we know it's there. And it ensures that we know any weak points and that we deal with them. So overall, we end up with a high quality, safe, and secure product. So, functional safety standards concentrate on the risk caused by the malfunctioning of a system. But how is this different for AI? Well, the problem here is with AI, the system is no longer deterministic. When we've got a static piece of code, we know if we do this, this will happen. If you've got AI, we only know that we can say we want the overall effect to be this. So we don't know how it's achieved. So functionality has stepped into the spotlight. We have to think about our functionality, not our implementations. And this is because it's not sequential. This happens, so therefore that'll happen. It's more, this is our requirement, this is how it's achieved. So for AI systems in a safety-related environment, the functionality has become essential. Now, the first standard to consider this is ISO 21448, also known as SOTIF. And this is the safety of the intended functionality. Again, we're looking at the functionality, not exactly the implementation. As with any functional safety standard, it's looking at risks. And this particular standard considers the risks associated with functional insufficiencies, meaning we've got bits missing. This could be insufficiencies in the specification. We forgot some of the use cases. Or it could be in the implementation of the specification. Or it could be in the performance. It's not doing this implementation as well, or indeed as we thought it would. So this is where SOTIF is focused. So SOTIF, what does it do? It provides guidance on the design and verification and validation, and also the activities during the operation phase that are needed to achieve and maintain the SOTIF. The SOTIF being, of course, the safety of the intended functionality. The scope of the standard is reasonably foreseeable misuse, plus some external communication. So it's misuse that we can sort of think might happen. We're constantly with SOTIF thinking, what could go wrong? How would we deal with it? But even this isn't really enough for a system with artificial intelligence in it. Our current standards, I mentioned IEC 61508, our general industrial standard, has a lovely line in it. It says, artificial intelligence, fault correction is not recommended. So maybe that's not a good place to start. So our current functional safety standards do need to be updated, but because they deal with risk and challenges, the challenges of an AI system have to be identified. So first of all, we look at how the algorithms can be evaluated according to 61508. There's limited information here on the specification, design, and verification of the functionally safe AI system, and also how to apply AI technology for functions that have safety-related effects. The thing is, whenever AI technology is used in general, and especially when it's used to realise safety-related systems, special considerations are likely to arise. Now, there are techniques already available in the field which could be applied to AI algorithms. But how can we measure these? How can we put them into a standard which can be followed? Well, first of all, we have to look what the problem is. And AI can actually be used in many software areas. It can be used in the field. We can have the model running in the software. It's there continually, it's updating, it's learning, but it's actually in the application out there in the big wide world. It can be used in development. We can give an AI model a requirement for some software, and it can develop it. We can stop the model, we can put the software into the application, and it's there. And we can use it in tools, the tools that actually check the software, the tools that help develop the software, but of course they, again, would not be in the end application. So TR 5469 actually classifies AI according to the usage levels. The first one being it's been used in the field. The model is there, it's still learning. The second one is that it's used in development. We use it to help develop our code. And the last ones, C and D, are not directly in the safety path. So this could be tools, it could be all sorts of other aspects, but it's not going to actually affect the use of the end product. Now, also Develop has some classes, and class 1 can evaluate with the existing safety standards. We like that, it's nice and easy. Class 2 requires an appropriate set of requirements. Interesting. Class 3, there are no techniques currently, no. Now, looking at class 2, what is an appropriate set of requirements? So the next steps are to formulate this set of requirements. So TR 5469, which is the Artificial Intelligence Functional Safety Standard, is not the only one out there. As previously mentioned, industries tend to go for their own particular functional safety standard. And automotive have developed ISO PAS 8800, which is Road Vehicles Safety and Artificial Intelligence. So, what is this particular standard? Well, it's currently at the approval stage, and having checked, it's still there, which is why it has the PAS classification. What this does is extends ISO 26262, which is the automotive functional safety, to cover AI standards. But it also extends the concepts and guidance provided by SOTIF. It proposes risk reduction measures, those things that are absolutely vital to functional safety, during the design and operational phases, and it uses an iterative approach to reducing risk. Now, this is relevant for all usage of AI for which safety requirements can foreseeably be allocated, either through the use of AI for the functionality itself, or the use of AI as a safety mechanism. We've got an ordinary system, but we have AI that is spotting something out there. For example, it has started to rain, get the windscreen wipers on. So it describes this framework throughout the all the phases of development. It provides verification of AI systems, methods for testing AI components. In the same way as we would test an ordinary component, we need a way of testing our AI components. It looks at AI system integration and verification and gives guidance for that. Virtual testing versus physical testing, always a good thing to be able to test without actually going out into the world. And safety validation. And these measures assure the safety of an AI system during operation. Now, these days, wherever there is a functional safety standard, you can be sure that there will be functional security there as well. And AI is, of course, no exception. So cybersecurity is a particularly important area for AI. It's a necessary precondition for the safety, resilience, privacy, fairness, and reliability of AI systems. AI systems are subject to novel security vulnerabilities that need to be considered alongside standard security threats. But they have a high pace of development. It's so high that security can often be a secondary consideration, and this cannot be. Security must be a core requirement, not just at the development phase, but throughout the life cycle of the system. So, what are the requirements for functional safety? It requires that security is at the forefront of development and have considerations from the start and aim to build a culture of security, of ownership. The whole of the development is based on having security. They describe the functional requirements that enforces security, and it can be tested and observed to observe that developers have due diligence about their own software, that it is secure. And it is essential that there are software vulnerabilities identified, because at times software can be abused in ways that nobody ever imagined. So some industries have specific functional security standards. For example, automotive has ISO 21434. And there are also directives from national bodies in both the US and EU. And the basis of all these standards is to have in place a secure software development lifecycle, with all activities including security considerations. And also all staff must be trained in software security. And this means that security is baked in from day one of a project. And it's not just the concern of the software development team, but for everyone in the organisation. Now, as I mentioned, in both the US and the UK, we have national guidelines, or international guidelines, to be honest, because we all tend to use everything. And here are the two main ones. One is NIST, which has a secure software development practice for generative AI. And in the UK, from their National Security Centre, guidelines for secure AI development. Now, NIST, to use a more user-friendly name, or possibly not, it's known as NIST SP 800-218A, often you get requests, are you compliant to NIST 800? That's usually this one. And this aims to be a companion document to a general security software development framework. And it aims to identify additional risks, particularly linked to AI, and therefore the practices and tasks required to ensure the security of AI models. Doesn't sound too complicated, but there's quite a lot to it. We have to think about security through all of our practices to make sure that we have a secure product. The UK National Security Centre takes a slightly different approach. The basic guidelines mirror those of other functional security standards in that security needs to be the heart of everything in the organisation. But then it adds additional requirements for AI to look carefully at the model selected. Are there security benefits? And are there any additional risks with the model? So, guidelines are there for us to develop secure software. You must make sure that your staff are aware of the threats and risks that are always there. You model the threats into your system so that you can deal with them. You design your system for security, as well as just for the functionality and performance. And you consider the security benefits and the trade-offs when selecting your AI model. So, to conclude, safety critical applications are encompassing AI. We can't stop that. It is happening. We must take consideration of the effects. Safety and security are as important as ever. Just because it's an AI system doesn't mean that safety or security are no longer important. The difficulties of ensuring the safety and security of an AI system have been recognised throughout the software community. It isn't hidden away, we're looking into it. And because of this, new standards are emerging, but there's still a lot of work to be done. Thank you for your attention. Are there any questions?
Thank you, Jill. We have time for a few questions. The first question that came in is how to maintain versioning as required by software BOMs.
Oh, that's a tricky one. Because, of course, the software BOM requires that we can reproduce a system, and that's the reason for them. It's not possible to have a live model in the software that requires a software BOM. So currently, and this doesn't mean it's going to be like this forever, the model has to stop training when the version is released.
Next question, will the traditional functional safety standards be updated?
Yes, I think the answer to that is. Now, whether they're updated in that they have an additional standard associated with them, I'm not quite sure. I know there is work going on with some of the standards already to add AI guidance, but we may see more like we did with security and ISO 26262, in that instead of having a security part to that standard, 21434 was released. So it's possible that we will just get sort of the core standard and then a supplement, a bit like the 8800. Maybe that will evolve into a full standard. to be used in conjunction with ISO 26262. And I should imagine the same will happen in other industries.
We have time for one more. Is AI actually a good thing for functional safety then?
Is it a good thing? That's hard to determine. It's going to be a good thing in that it helps us consider safety, look at safety, and if we can train the models to have safety at the core, yes, it is a good thing. Currently, putting a learning model into a functional safe product is maybe a step too far.
Thank you very much, Jill. If we didn't get to your question, we'll reach out to you via email. And thank you to our audience for your attendance and participation today. We hope to see you next time.
Thank you.